Well, Lewis theory is one of the acid-base theories put forward by an American physical chemist, Gilbert Lewis, in 1923. So let's try to understand by taking an example. So here I have ammonia reacts with hydrogen chloride, HCl, this is in gaseous state, to form ammonium chloride. And from Bronsted-Lowry theory, we know that this is a Bronsted-Lowry acid. HCl is a Bronsted-Lowry acid, which means it gives a proton to an H plus to ammonia. So a Bronsted-Lowry acid is a proton donor, and ammonia is a proton acceptor, so we call that as a Bronsted-Lowry base. Now the important question is, why does this proton or hydrogen ion migrate or is attracted to ammonia? So let's try to understand this. So I have ammonia, NH3, and there is a lone pair of electrons on the nitrogen atom in ammonia, and here we have H plus from HCl, which is coming from here. So this has no electrons, so this is 0 electrons. It's electron deficient. Electron deficient. And the reason why this proton is attracted to this ammonia is to overcome that electron deficiency. It wants to become stable in the chemical world. So how can this proton or hydrogen ion overcome that electron deficiency and become stable? Well, you have this nitrogen atom bearing a lone pair of electrons, so this nitrogen gives a pair of electrons to this hydrogen ion, and this pair of electrons are equally shared by the two. Now the hydrogen becomes stable because it owns that pair of electrons as well. Of course they belong to both of them, but eventually, since the nitrogen is donating a pair of electrons to hydrogen, it's stable now because it gets 2 electrons. Previously it had 0. And Gilbert Lewis called species like these, electron deficient species, as Lewis acids. So a Lewis acid is electron deficient. What about molecules or ions that are electron rich? So for example, this nitrogen has a lone pair of electrons. It has an extra pair of electrons. So he called electron rich species, electron rich species, as Lewis base. Right? So let's take another example and understand a little bit more about Lewis theory. So let's say I have boron trifluoride. We all know boron trifluoride, BF3, and then we have ammonia. So what's so special about boron trifluoride? So let me write the electron configuration of boron trifluoride. Well, boron has 3 valence electrons. You can look at the periodic table, you can get the proton number, and you can do this. So boron has 3 valence electrons, and it shares 3 electrons with 3 fluorines in this fashion. And fluorine has 7 valence electrons. Out of 7, 1 is being shared with the boron, so there will be 6 electrons remaining, which we show them as 3 pairs. And this fluorine also has 7. It shared 1 with boron. Now it has 6 more remaining. And this fluorine also has 7 valence electrons. It shared 1. Now it has 6 remaining, which can be shown as 3 pairs. So if you look at the number of shared electrons around, or the charge centers we call them, around the central atom boron, you can see 6 electrons around boron. So for a molecule to be stable, that's not a good sign. it's falling short of 2 electrons. So to become stable it needs 8 electrons. So how can boron trifluoride, which is being electron deficient, so 6 electrons is electron deficient, how does it overcome that electron deficiency? So what it does, what happens is the nitrogen in ammonia, it has a lone pair of electrons. You can also write the electron configuration of nitrogen and then draw the Lewis structure of ammonia in this fashion. So nitrogen Lewis structure is like this. So this is the Lewis structure of ammonia, where nitrogen in ammonia, the central atom, has a lone pair of electrons, or a non-bonding pair of electrons. So since this boron trifluoride is electron deficient, this nitrogen bearing the lone pair donates a pair of electrons to boron trifluoride. So that is 6 electrons originally. So now it becomes 6 plus 2 electrons. So now boron trifluoride is stable. So Lewis called this as a Lewis base, or a base. He called it a base named after him because it can donate a pair of electrons. So Lewis base donates a pair of electrons. So this is a better definition of Lewis base, donates a pair of electrons. Or in other words, you can call the Lewis base as an electron donor because it's donating electrons. So I can call this as electron donor, not the donor that you eat. Electron donor. So if this ammonia is electron donor, I can call this BF3 as, of course it's a Lewis acid. I can call it an electron acceptor. Right? So that's the driving force. So an electron deficient molecule or an ion can overcome its electron deficiency by accepting a pair of electrons from the Lewis base.